105. What is the effect on the amount of CaHPO4 that dissolves and the concentrations of Ca2 and HPO4 minus when each of the following are added to a mixture of solid CaHPO4 and water at equilibrium? And then we have NaOH. So in this case, we have to figure out what's going on with CaHPO4 and the calcium ion, Ca2 and HPO4. This technically should be a 2 negative. So maybe I'll just put that here. But it doesn't matter. But we basically just have to figure out what's going on with those when we add NaOH. Now, first thing is I already wrote out the balanced equation. And if you want to know how we wrote this down and why it is what it is, go check out 105A. That's where I go into depth and I actually write this equation. But for this one, we're just going to get right down to it. So, NaOH. We've seen this, especially last chapter, right? The acid and base chapter. NaOH is a strong base. And strong bases are going to break down or disassociate 100%. So NaOH is going to break down into its two charges, one positive, one negative. So I have Na+, that's for the sodium, and then I have OH-. Okay, that's great, but how do I convert this into my actual equation? Well, hopefully one of them matches. But as I'm looking at this equation, I don't see any Na+ or OH- in this equation. So I can't just transfer over what's going on over here. Now the next thing is maybe there's an acid-base reaction. Well, let's see. For Na+ and OH-, I do see that I have a OH- here, right? I have a hydroxide. Maybe the hydroxide being the base, right? Because bases are the negative, and it's going to react with something that can be an acid, right? So I have my OH-, that's definitely the base. So I have OH-, but now I have to figure out which one of these is going to act as the acid. Well, remember, the acid has the acidic hydrogen, and the acidic hydrogen is always in the front. This HPO4 2- has the H in the front. This is classified as an acid. So OH- plus HPO4 2- is going to basically come together to form a reaction. Now, do we really care what the reaction is? Not really, but I'll write it anyway. Right? If this is the base, it's going to take the hydrogen, so you're going to get water. And then you're stripped away of the hydrogen, so it would just be the phosphate ion, PO4 3-. But now, if this HPO4 is now going with the OH- to form another reaction, right? It seems like it's literally going away from this equation. And if that's the case, you're not going to have enough for this equilibrium reaction. So the HPO4 2- will decrease. So that answers 1 out of the 3 questions. But now the thing is, what's going to happen with calcium and what's going to happen with the CaHPO4? Well, this is going back to Le Chatelier's. In this case, we have too little of an amount, right? A decreased amount. And when you have too little, you got to get it back. So you will always shift to the same side. So in this case, we are having a little trouble here in the product side. So my overall equilibrium is going to shift to the forward reaction because I want to get that back. And if you're going this way, the calcium 2+ is going to increase. And since you're using this up to break more down, your CaHPO4 will decrease. And there are your 3 effects. So the CaHPO4 will decrease, the calcium 2+ will increase, and the HPO4 2- will decrease. And that's it. I really hope this helped you out. Let me know in the comments. Thank you so much for viewing the video. If you want to help us out, please press the subscribe button. And I hope to be talking to you in future lessons. Okay, bye-bye.